So I'm talking about the creation of a circular economy for salvage lumber from the King County perspective. There's a lot of work we've been doing at the state level too. I'll talk briefly about that at the end. We're running a little short on time, so I'll go a little bit fast. But hopefully we'll have a little bit of time for questions at the end. So what is King County's interest in all of this? There's about 350,000 tons per year of unpainted and untreated wood that is being generated in King County and Seattle, so at job sites, basically. About 60,000 tons of that is going through the King County-owned transfer stations and going to the King County landfill. And we're trying to save space in that landfill for as long as possible. And the way the state codes are written, we have a responsibility for any C&D waste and making sure that that's managed appropriately. And so if there's a lot of material in there that could and should be going to higher and better use, we feel like we have the responsibility to be guiding that material in a better direction than how it's currently being used in a landfill or going to industrial boiler hog fuel. So down in in our hierarchy of wood uses, in red, you can see the two main directions that clean wood is going right now. And we developed this a couple of years ago. It's based on carbon impacts, embodied carbon, a couple of other factors, including impact on public health and the environment. But basically, we are thinking that probably we should be aiming for higher and better uses, meaning stuff at the top of the chart, right? So whole wood reuse, finger jointed boards, mass timber assemblies. That's kind of where we're aiming for. And in order to frame this, we set a vision. Basically, we're working to put a system in place that will take these materials from buildings and put them back into new buildings and lock up that carbon, reduce the embodied carbon of the materials going into the buildings, and create a number of other benefits along the way. So looking at it from a circular economy perspective, this is kind of a crude diagram, but it does a good job of capturing the basic concepts. So up in the top right corner, we've got building deconstruction, right? That's where Dave's coming in, taking the buildings apart, harvesting the materials. As we see it, these materials would go, and we're talking primarily about dimensional lumber. So 2x4s, 2x6s is what we're focusing on initially. And I'll talk about that a little bit more in a minute. But basically, once the buildings are deconstructed, the materials go on to basic processing. Then we'd go to a salvage lumber warehouse where they would go through a lot of different steps. I'll talk about that more in a few minutes too. Then get finger jointed. Then the material would go on as lamb stock or finger jointed boards into manufacturing, get put into panels, and then go out for distribution and into new buildings. And then the bit that Brad was talking about kind of is up at the top, or between the manufacturing and the distribution and construction, really, of making sure that when those buildings are designed with the panels, that they're designed in a way that they can be disassembled. And that's one of the things that's really attractive about mass timber assemblies, is the potential for disassembly. So when you're looking at a building like this that has really large timbers in it, it's pretty easy for people to envision how this material could be reused. So we're not spending a whole lot of time focusing on this. There's warehousing issues, there's design issues, there's a number of issues that are wrapped up in reusing this material. But as we develop the larger system, we're allowing for warehousing space that would be needed to help get this material back into reuse and for additional guidance. So we're really working on tackling the tougher stuff that's out there. So this is the kind of lumber that we see going through our transfer stations. This is actually after it's been run over once or twice usually and getting ready to be put into a dumpster to be hauled off somewhere to get ground and then turned into hog fuel. So we're figuring that as we're salvaging material, if we were to start pulling it out of the waste stream now, this is what it would be looking like. We're going to be working with contractors and haulers also to be capturing this material further up the waste stream, so it's in larger pieces. But as a worst case scenario, this is what we're looking at. And even with these materials, we're looking at somewhere around 50 to 80% of the material could be captured for reuse and finger joining into new material. So this just highlights the two areas we're focusing on in our hierarchy. And really, this is what we're trying to get to, right? So we're trying to figure out a way to take all those little pieces of boards and connect them in a way that they can be structural, that they can go into a building. We can lock up that material for another 200 years, hopefully, if the building's designed well and designed to be adaptable. Brad talked about that a little bit. And then eventually, when this building's taken down, most estimates are roughly 70 to 80% or possibly more of the panels within this building could serve another life, being reused in another structure. So a little bit more about the Salvage Lumber Warehouse. We're working on taking boards, sending them through an AI-assisted inline assessment and processing system. One of the big issues, and there's one question about it already, but one of the big issues with salvaging lumber is trying to get similar materials. If you're taking down a bunch of buildings and you're taking the wood from those buildings and you're mixing it all together, you've got a lot of different, sometimes species. Around here, it's mostly Doug fir, but there's a lot of densities. That's the biggest issue. And a lot of different qualities, all right? So we might be getting some that's offcuts from new job sites. That's going to be significantly different in its properties than what's coming out of a 100-year-old house that Dave Bennick helped take down. And so we need to have a facility that can assess that material and get it sorted according to the key properties. Densities and strength are the two main properties that we're going to be sorting for. And then materials would be batched together and would go on to various uses. So whole boards would be, reused as studs as they are, but we know that a huge majority of the material is shorter than 8 feet. And those pieces would be getting cutted, finger jointed, made into lamb stock, and then sent on to various engineered uses. So we see the Salvage Lumber Warehouse as part of a larger campus. We call it the Sustainable Wood Business Park. And there's a lot of different companies. Some already exist, some have expressed interest, and we know there's still others out there that that we haven't found yet that would make a lot of sense to co-locate with the Salvage Lumber Warehouse. How do we get there? Real quickly, King County and clean wood from going into landfills. We've been working it into our policies. We a couple of years ago worked it into our strategic climate action plan. We have one line in there that says we're going to support the transition to a reusable wood market. We've been able to rely on that pretty heavily for helping move our efforts forward. At the state level, we worked with the state building code. It's now available in both the residential and commercial codes. It's referred to as used sawn lumber. I've got the code information on the next page I'll show you, but basically it states that if the material is 2x6 or less, it should be assumed to be spruce, pine, fir, and if it's 2x8 or 4x and larger, it can be assumed to be hem fir number 2 grade. And those are the assumed grades, so it does not have to have a grade stamp on it anymore. I'll switch to this so you guys can write that number down if you want to capture the WAC for it. But basically, this makes it so that you no longer have to have a lumber grader come out and look at each and every individual stick of lumber. So it saves a lot of time and a lot of cost on projects. We recently got into the state building code 2 appendices related to C&D, construction demolition materials. The key point for this industry is that they require the submission of a salvage assessment. So that's kind of the first step in getting people into the buildings, thinking about what's there that could be salvaged. It's not a huge step, but it's a first step. And as appendices, I should also note that these are available for individual jurisdictions to adopt. It's not a requirement, but they can say we want to adopt Appendix P and it becomes part of their code. So it's a jurisdiction by jurisdiction adoption at this point. Then we also have Appendix Z, which is also an elective code for jurisdictions. And this has to do with building deconstruction. If they decide to adopt this, basically applies to single family homes larger than 750 square feet that are 90 years and older. They can request a waiver or a variance on that and make it fewer years. We have one city that's looking at making it 70 years. And basically it says the building has to be deconstructed instead of being demolished. So these are just a couple of ways that we're working on moving the industry forward, working to get that lumber out of buildings in a more usable fashion. And our next step really is to find a location for the Salvage Lumber Warehouse. We've applied for a $4 million EPA grant. City of Seattle has done the same. For Salvage Lumber Warehouse, we're partnering on that. We've got, if Seattle gets their grant, King County can move forward, and we get the grant, we can move forward with working more on the Sustainable Wood Business Park concept, the way we wrote it. But that's what we're working on the most at the moment. I just wanted to leave you with these thoughts. These actually kind of are based on some ideas that Brad threw out there, but basically that we should recover the resources that we have, reuse these resources wisely, and then rethink about how to design for the future, so that in the future, when we're recovering the resources and reusing the resources, they can get used for their highest and best use. And we won't have to put nearly as much energy and embodied carbon into processing that material to get it back into the cycle again. And that's it for my presentation.